this lesson, we're going to continue talking about the area of a circle, but now we'll talk about also about the area of a sector and also geometric probability. So the first thing we're going to do is define a sector. So a sector is a region bounded by two radii. Remember, radii is plural of radius. And their intercepted arc. So this here is a sector of a circle. If I want to find the area of a sector, it's also going to be set up just like we did for arc length. We're going to have degrees over 360. And now it's going to be the area of the sector over the area of the circle. All right, and we usually use then pi r squared for the area of the circle. So our first example, we want to find the area of the red sector, and that's the one that has an arc of UV. So I'm finding this sector right here. So knowing I'm going to use degrees over 360 equals the sector's area over the whole area. We're going to have 70 over 360. Area of the sector is what we're looking for, so x over, and the area of the circle using pi r squared, we know r is 8, is pi 8 squared. So cross multiply this, we're going to get 360x equals 14074.34. Divide both sides by 360, and we get about 39.1 inches squared. All right, so just like regular area was inches squared or feet squared, units squared, so will be the area of a sector. Another one, we're going to find now the area of the blue sector. So that's the one with arc USV. So really, it's everything except the red sector, which means its degrees are everything besides 70 out of 360. So if I subtract 70 from 360, we get 290. So that's actually the number of degrees we have. So degrees over 360 equals, we're still looking for the area of the sector, so that's x over, once again, pi 8 squared. So when I cross multiply, I get 360 x equals 58,307.96. Dividing by 360, we get about 161.97 square inches. So you're going to try the check-in, pause, when you're ready to see the answer, hit play. All right, so that's 120 over 360 equals x over pi times 14 squared, and we get about 205.25 square feet. For example 3, we want to find the area of the whole circle. We don't know what the radius is, but we do know how many degrees the sector is and the area of that sector. So using our formula, write it out once again, degrees over 360 equals the area of the sector over the area of the whole circle. I know degrees is 40. I know the area of the sector is 35. And I'm looking for the area of the whole circle, which I could just leave as a. I don't have to put pi r squared there, because that would mean I'm kind of solving for r, and I'm not. I'm just solving for the whole area. So cross multiply, we get 40a equals 12,600. Divide by 40, we get about 315 meters squared. So we're going to take all this knowledge to help us find the area of a shaded region. And there's two ways we can find shaded regions. The first one is when we have an entire shape, but we took some of it away, right? So I'm looking at one big shape here. We're looking at a wall we want to paint, but there's a door within that wall. So the big shape is really one big rectangle or square. I think this is actually a rectangle. I know that this dimension is 36 and this is 10 plus 16 or 26. So my whole rectangle is 36 by 26, and I get 936 for the area of the wall, including where the door would be. But I'm not going to paint the open space that's the door, so I need to take those parts away. So I have two different parts in here that I'm going to take away. First, I have this square that has dimensions of 16 by 16. That's 256. And I also have this semicircle. I know it's half of a circle and the radius is 8. So for my half circle, I'm going to do half of the formula for area, which is pi r squared. So this is 64 times pi times a half, or 32 pi, and I get about 100.53. So I can either add these together first and then take it away from the 936, or just do 936 minus 256 minus 100.53, and overall I should get 579.47 square feet. All right, so this first kind was where we found the whole shape and we took away what was unshaded or not included. In our next example, we want to find the area of this figure, and we're going to do it instead by just combining two shapes because there's nothing unshaded, nothing taken away in this problem. So the first thing I have here is a triangle with a base of 7 and a height of 7. So for my triangle, we know the area formula is 1/2 times base times height. So I get 24.5 here. Then I have my semicircle with a radius of 3.5. So for my semicircle, we're going to find half of the area of a regular circle, which is pi r squared. So we actually get about 19.24 here. So the area of the whole shape is these two combined. So I get a total area of 43.74 meters squared. You're going to try the next one. Find the area of the shaded region. Pause. When you're ready to see the answer, hit play. All right, so this is a rectangle minus 2/2 of a circle, which is actually one whole circle. So the rectangle I found by doing 13 times 6. The circle I found by doing pi r squared, where r was 3. So we get a total area of about 49.73 square units. The last thing we're going to talk about in this lesson is geometric probability. So probability in general is the likelihood that an event will occur. So we find probability by dividing the favorable outcomes, what we're looking to happen, as out of all possible outcomes. So for geometric probability, because we're looking for the probability that we are selecting part of a shape, we're going to have the area of the particular region we're looking for divided by the area of the entire region. And that is how we will find the geometric probability. So for this one, we want to find the probability, assuming that a dart is equally likely to land on any part of this shape. What is the probability it would hit the inner circle as opposed to the outer circle, right, out of the whole thing? So the inner circle would be pi 2 squared, and the whole shape would be pi 4 squared. So really the pi's cancel, so now I have 4 over 16, which is 1/4. We could leave it as 1/4, or I could turn that into 25%. So you're going to try the next one. We want to find the probability that a fly lands in the circle when it lands on this hole shape. So pause when you're ready to see your answer, hit play. All right, so it was the circle over the total, which happened to be the square. The square was the total shape. So that was pi r squared over length times width. So we get 254.47 over 324, which when we divide gets about 0.785. So that's about 78.5% probability. And that is everything we're going to talk about for area of a sector and geometric probability.